Imagine a world without computers, smartphones, or the internet. This was our reality before the invention of the transistor. This tiny device, smaller than a fingernail, revolutionized the world of electronics. Our journey begins in the 1940s at Bell Laboratories. Scientists John Bardeen, Walter Bratton, and William Shockley were working on a problem. They wanted to replace bulky, inefficient vacuum tubes in electronic devices. Their invention, the transistor, would change everything. On December 16, 1947, these brilliant minds demonstrated the world's first working transistor. It was a pivotal moment in technological history. This tiny device could amplify electrical signals just like a vacuum tube, but with significantly less power and size. The invention of the transistor marked the dawn of a new era, the age of miniaturization and modern electronics. Little did they know, this tiny device would change our world in ways they could only imagine. Before transistors, vacuum tubes were the heart of electronics. These glass tubes controlled electrical currents, enabling radios, televisions, and early computers. But vacuum tubes had significant drawbacks. They were large, fragile, generated a lot of heat, and consumed enormous amounts of power. Transistors, on the other hand, were small, durable, energy efficient, and generated minimal heat. They quickly proved to be far superior to vacuum tubes in every way. The adoption of transistors was swift and transformative. Electronics manufacturers were eager to utilize this new technology. They began replacing bulky vacuum tubes with these miniature marvels. The transition from vacuum tubes to transistors had a profound impact. It paved the way for smaller, more powerful, and more reliable electronic devices. The impact of transistors on the size of electronics cannot be overstated. As transistors replaced vacuum tubes, electronic devices shrank dramatically. This miniaturization revolutionized the design and functionality of countless products. Radios, once bulky pieces of furniture, became portable. Computers, which used to occupy entire rooms, could now fit on a desk. This miniaturization opened up new possibilities for electronics. The shrinking size of electronics also led to reduced manufacturing costs. As transistors were cheaper to produce than vacuum tubes, electronics became more affordable and accessible to the masses. This era of miniaturization fueled by transistors led to an explosion of innovation. It set the stage for the development of even more sophisticated and compact electronic devices. As transistors shrank, a new challenge emerged, connecting these tiny components efficiently. This led to the development of integrated circuits, also known as microchips. In 1958, Jack Kilby at Texas Instruments and Robert Noyce at Fairchild Semiconductor independently invented the integrated circuit. This groundbreaking innovation involved building interconnected transistors and other components onto a single piece of semiconductor material, typically silicon. The integrated circuit was a major breakthrough in electronics. It enabled the creation of even smaller and more complex electronic circuits. This paved the way for the development of microprocessors, the brains of modern computers. The invention of integrated circuits marked another turning point in the transistor revolution. It propelled us further into the digital age and laid the foundation for the sophisticated electronics we rely on today. Section 5. The microchip miracle, powering the digital age. The development of integrated circuits led to the creation of microprocessors, complex circuits etched onto a single chip. These microchips became the brains of computers, controlling everything from basic operations to complex calculations. The first commercially available microprocessor was the Intel 4004, released in 1971. It contained over 2,000 transistors on a single chip and ushered in the era of personal computing. Microprocessors rapidly evolved, becoming more powerful and capable with each generation. This progress, driven by the relentless miniaturization of transistors, became known as Moore's Law, which observed that the number of transistors on a microchip doubles approximately every 2 years. This exponential growth in processing power fueled the digital revolution, leading to the proliferation of personal computers, the internet, and countless other technological marvels. Section 6. Transistorized world, from calculators to supercomputers. The impact of transistors extends far beyond computers and smartphones. These tiny devices are ubiquitous, found in almost every electronic device imaginable. In our homes, transistors power our televisions, refrigerators, washing machines, and countless other appliances. In our cars, they control engine performance, safety features, and entertainment systems. Transistors are also essential in industries like healthcare, manufacturing, and aerospace. From medical imaging equipment to industrial robots to aircraft navigation systems, transistors play a vital role in our modern world. The pervasiveness of transistors is a testament to their versatility and impact. They have become the unsung heroes of the electronic age, silently powering the devices we rely on every day. Section 7. The heart of communication. Transistors in radios, televisions, and beyond. Transistors revolutionized communication technology. They replaced bulky, inefficient vacuum tubes in radios, making them smaller, cheaper, and more reliable. This led to the widespread adoption of transistor radios, bringing music, news, and entertainment to people around the world. In television, transistors replaced bulky and power-hungry vacuum tubes, making televisions more compact and energy efficient. This paved the way for the development of color television and large-screen displays. Transistors also played a crucial role in the development of satellite communication, mobile phones, and the internet. They enabled the transmission of information over long distances, connecting people and ideas like never before. The impact of transistors on communication technology has been profound. They have shrunk the world, connecting us through various media and enabling instant global communication. Section 8. The future is tiny and powerful. Transistors in nanotechnology and beyond. As technology continues to advance, transistors are at the forefront of innovation. Scientists and engineers are constantly pushing the boundaries of miniaturization, developing even smaller and more powerful transistors. Nanotechnology is playing a significant role in this progress. Researchers are exploring new materials and manufacturing techniques to create transistors at the atomic scale. These nanoscale transistors have the potential to revolutionize electronics once again. Imagine computers millions of times faster than today's most powerful machines, or smartphones with batteries that last for weeks on a single charge. These are just a few of the possibilities that nanotechnology and advanced transistor design hold for the future. The relentless pursuit of smaller, faster, and more efficient transistors continues to drive innovation, promising a future filled with even more sophisticated and powerful electronic devices. Section 9. Transistor Legacy, a foundation for endless innovation. The invention of the transistor was a watershed moment in human history. This tiny device, born from the brilliance of scientists at Bell Laboratories, ignited a technological revolution that continues to shape our world. From the miniaturization of electronics to the rise of the digital age, transistors have been the driving force behind countless innovations. They have transformed the way we live, work, and communicate, connecting us in ways that were once unimaginable. As we look to the future, one thing is clear: the legacy of the transistor is far from over. As researchers continue to push the boundaries of miniaturization and explore new frontiers in nanotechnology, the transistor will undoubtedly remain at the heart of innovation, driving progress and shaping the future of electronics for generations to come.